Our next presentation is entitled Yield Loss and Great Effects of Peanut Combine Speed Settings, and our presenter is Benjamin Fogle.
Hello, everybody. Hope everybody's having a good day today. I'm trying to share my screen. Okay, so today I'm going to talk to you about yield loss and great effects of peanut combine speed settings for both the 2018 and 2019 seasons. This is my graduate research from both the 2018 and 2019 seasons, and after last year, I think I'm done, hopefully. But the purpose of the test was to determine combine efficiency and basically to figure out where most of the losses were coming from, whether the header or from the rear of the combine. We changed 3 different settings while we tested in 2018 and 19, the PTO speed, header speed, and ground speed. These 3 were the easiest things that we could change on the go and easiest for a grower to change on the go. And we kept all the other factors the same on the combine. And as we changed these three factors, we also looked at percent LSKs and percent foreign material as it related to peanut grade. This is a picture of an Amatis peanut combine. We used an Amatis 2108, which is a 4-row machine. A lot of the growers around here in South Carolina use Amatis combines to harvest their peanuts. So we thought that that was a good thing and relatable to South Carolina growers. This is an example of what one looks like on the inside, just as a reference. Going into the materials and methods on how we collected the tailings losses, we had to construct a trailer that attached to the axle of the combine that basically followed the combine, and we had a tarp on top of that whenever we got to the end of the plot, we would pull the tarp back and we would weigh the tailings that came out of the back and separated them from the vines using the green combine down in the lower right picture. Without that combine, we would not have been able to do the study that we did. This is a little bit of the cart design and how it attached to the combine. And getting into how we collected the header losses, we stretched out a tarp. It was a 4x12 foot tarp, and it went across 2 adjacent rows, windrows, and we lifted up the windrows by hand gently to reduce losses that way. And then we pinned the tarp down, and we had a time with the first couple of plots maybe getting wrapped up into the header, but after we got it kind of figured out, everything went smoothly. So getting into the 2018 field plot layout, this was the plot layout for 2018. Each plot was 63 feet long and 4 rows wide on a 38-inch row spacing. We had 125 total plots, but we only got sample weights on 85 of those. We planted Bailey's that year, which is a Virginia type, and as many of you guys know, 2018 was not favorable for growing peanuts at all. So there was a lot of time in between when we dug them and when we harvested them. And these were on a randomized block treatment design. These are the treatments that we had. There were 25 treatments with 5 replications, and I'll get into a little bit of this later. This is the 2019 field plot layout. Again, we kept the plot size the same. There were 150 total plots this time. 75 of those we only got sample weights on, and that's what we considered the wet test. The wet test was 3 and 4 days after digging, and the dry test that we had, which is in blue, was 18 days after digging. And we did this to see if moisture had any effect on grade and yield loss. These were planted in Flow Runner 311s. So we have a test in 2018 with runners, or 2018 with Virginias, and 2019 with runners. And these were the treatments here. So here are the findings from 2018 and 19. This slide kind of shows the differences, the trends, the no differences, and the findings that we were surprised about. Same with this slide here. I broke it down into the wet harvest and dry harvest. In 2018, we saw that there was a function of, or a relation between header losses and header speed. We saw that at the slower speeds, the header losses were greater. We kind of came up with the hypothesis that maybe at these slower speeds, the peanuts were just sitting there getting beaten by the header teeth before they even got into the combine. So we had some of the sloughing or kind of knocking off of the peanuts at that point. We saw 53 pounds per acre yield loss for every 15% increase in header speed. We did not get any data from 2019 due to inconsistent data collection. Now I'm going to talk about the LSKs as a function of ground speed. In 2018, I'm going to go through each one of these graphs here, and I'm breaking them out kind of one by one. But in 2018, we saw that for every half-mile-an-hour increase, we saw about a 4% decrease in LSKs. And this could be due to the not proper loading of the combine. And whenever you properly load a combine, there's a cushioning effect that happens within there. And when it's not properly loaded, that sometimes it'll really damage your peanuts. In 2019, in the wet test, we saw that there was no real relation, but I suspect that that it's a similar trend to others, but the variance made it hard to see. And in the dry test for 2019, we saw that downward trend also. And we saw roughly a 3.2% decrease in LSKs for every 0.5 mile an hour increase in speed, in ground speed. Filler material had a similar relation here with that downward trend in 2018, and in 2019 for the wet, we really didn't see any kind of trend there. And then in the dry test, we didn't see anything either, but you notice that one point at 10.6% in the middle for the medium speed. We did a lot of changes at this medium speed, and it might have affected some of these grade effects. So we're going to be looking into that a little bit deeper as time goes on. A trend that we saw was the tailings losses as a function of ground speed. In 2018, it doesn't really show much of a trend. It kind of goes down and then goes back up. But in 2019, we saw that downward trend. And this downward trend basically shows an increase in ground speed could relate to a decreased tailings losses yield, but we didn't see any significant differences here. Next, the percent LSKs versus PTO speed. We saw in 2018 that there was a little bit of a downward trend, but no significant differences. But in 2019, we saw that upward trend there and significant differences also. In 2019 for the wet test, we saw for every 10% increase in PTO speed, there was a 2.3% increase in LSKs. And then also in 2019 for the dry test, we saw a 3.6% increase in LSKs as we changed the PTO speed. For material, similar situation. We had a little bit of a downward trend in 2018. No significant differences there. No consistent trend. 2019 for the wet test, we saw an upward trend, but really no significant differences. And in the dry test, we saw some significant differences, but they weren't very consistent to what we saw in the percent LSKs. So now probably the most important and significant findings of my research was tailings losses as it related to PTO speed. We went into the test knowing that there was going to be some losses coming out the back end of the combine. And we figured that was probably going to be where the majority of them were going to be. But we didn't realize it was going to be this significant as it related to PTO speed. And we saw in 2018 with runners, with Virginias, that for every 10% increase in PTO speed, there was approximately 140 pounds per acre increase in tailings losses. Note that there was no optimal speed found for minimizing yield loss. This could be looked at further for later research, but for the purposes of my research, this was not looked at. And in 2019, these were runners. There was a 58 pounds per acre increase in tailings losses for every 10% increase in PTO speed. And the differences between these two years is 2018, it was planted in Virginias, and in 2019, it was planted in runners. And as a lot of you guys know, that when you're harvesting Virginias, you don't really want to look behind you because you see some losses on the ground, some coming off the vines before they even get in the combine. So there's more losses associated with Virginias normally. Yield as it related to PTO speed in 2019, the dry test, we saw that for every 10% increase in PTO speed, there was roughly a 381 pounds per acre decrease in yield potential. This was the most significant out of the 3 studies that we had here. And in 2018, there was a finding that we weren't really going into the test trying to find, but it kind of found us, I guess. We found that there was a relation between tailings losses and combine throughput. And in 2018, we found that there was a sweet spot of about 20,000 pounds of dry material per hour in the combine to reduce tailings losses. And this was very shocking to us. And as I said earlier, I had another important finding. This was probably second to that finding. It was very, very important. But for 2019, we haven't really gone through all the data yet. It's a lot of data to go through, but it's undetermined at this time if there's a relation there. And like I said, we still have to do some analysis to determine the relationships. So in conclusion, we found in the 2018 and 2019 data that there was an optimal vine load on the combine for 2018, but not really sure for 19. There was a ground speed that affected the percent LSKs in foreign material in 2018 and 19. Ground speed increased header losses in 2018, but not seen as much in 19 because of that inconsistent data collection. Ground speed affected tailings losses, and this may be due to not properly loading the combine. We only saw this in 19. In 2018, we saw that header speed affected header losses. We didn't see it much in 2019, even with the inconsistent data collection, but we did see it in 2018. And PTO speed affected tailings losses in both 2018 and 19, which basically goes to show is slower better, and if the material was being thrashed too fast. And then PTO speed was affected, or it affected percent LSKs and percent foreign material in 2018 and 19. And with that, I'd like to acknowledge APRES Industries, Clemson University, all the people on the Precision Ag crew here at the Clemson Edisto Rec, and the Ag Making Business undergraduate program, my committee advisor, Dr. Kendall Kirk, my committee members, and my patient fiance for helping me with a lot of the data collection.
Thank you very much for that presentation. We have a question from the audience for you. And the question is from Dr. Barry Tillman. Was there interaction between ground speed and header speed for header losses? That is it important to somehow synchronize ground speed and header speed to minimize losses at harvest?
So the question was there a difference if you synchronize header speed and ground speed? We have not gone through and combined those two factors yet. That's going to be actually part of my thesis. So my thesis work, and I haven't gotten to that point yet. But if you would like to know what I find here in the future, if you could send me an email, then I would be more than glad to follow up with you on that. I apologize for not having an answer today, though.
Okay. A second question would be, when you talk about the 90%, the 100%, the 110%, how does the average grower, how does the average peanut farmer at harvest determine what PTO speed to use?
So the 90%, 100%, and 110% are all based on manufacturer recommendations. The 100% is 790 RPMs on 1,000 PTO shaft. And that's what's recommended by Amatis Industries to run is at 790. So we consider that to be 100%. That will change according to your vine conditions and load conditions on your combine. And also if you have somebody walking behind the combine, you can see, if there's additional losses at those higher or lower speeds. So that's just something that as an experienced grower, you would change on the go.
Okay. That concludes our time for questions. Thank you for your presentation. Enjoyed it.
Thank you.